In this video, I want to discuss a rule for when you have a function that is a quotient. All right, a rational function as they're called. So for example, f of x equals x plus 1 over x plus 2. Okay, that's an example of a quotient. And so I'm going to give you a rule on how to find a pattern to find the derivative of such a beast. Okay, now let me make something clear. Maybe you already knew this, but let me just remind you. So we've given you, you have now patterns for a product. You have patterns for sums of functions, differences, a function multiplied by a constant, a power. Okay, let's remember what we did. A derivative is still equal to a specific limit. In fact, it doesn't hurt for me to write it a couple more times. So the derivative of, in this case, f of x, you can write it as this right here. So that would be yet another function that we refer to by f prime. That's the derivative. Okay, now, so just to remind you, when I say that I'm giving you a pattern, I'm giving you a rule for a certain type of derivative, what that really means is that if you were to work out the limit, and if you were to play around with the limit and move some things around and change the appearance, it would always, if it started out with a certain form, it would always end up with yet another form. Okay? So the derivative definition hasn't changed. We're just allowing you now to skip the limit stage because it's going to turn out that if you did work out the limit, you would always get this same pattern in certain situations. Okay? So having got that out of the way, if you were to work out the limit that I just wrote on the whiteboard when you had a rational function and when you had, let's say, let me write it first in a cutesy way that's easy to remember, and things that make things easy to remember are always good. So let's say, let's call the top function, well, top, and then let's call the bottom function bottom. Okay, so the derivative of something that has a top divided by a bottom is going to be equal to bottom times the derivative of the top minus, not plus, minus the top times the derivative of the bottom all over bottom squared. Okay, so I've said that for over 20 years. It's just, for some reason, it's just easy to remember, and it's clear when you call things top and bottom. Just like for the product rule, for 20 years plus years, I've said first times derivative of the second plus the second times derivative of the first. You can have your own way to memorize it. If you like my way, go ahead and steal it. That's fine with me. So let me say this one more time. Bottom times the derivative of the top minus top times derivative of the bottom all over bottom squared. Okay? So for this specific function, if we were to use this pattern, first we need to identify what the top and the bottom are. And in this case, the top is the x plus 1, of course, and the bottom is the x plus 2. Okay, so putting it all together, we're going to get bottom, in other words, x plus 2, times derivative of the top, derivative of x plus 1, well, that's 1. Okay, minus the top times the derivative of the bottom, well, that's 1, all over bottom squared. And at this point, there you have a derivative. Now you could simplify it if you like, kind of clean it up, do some algebra. So on the bottom, I hope you can see that you would have x minus x and 2 minus 1. So 1 over x plus 2 squared is as good as it gets. Okay? So that, in a nutshell, is the quotient rule. Now let me give you some let me give you some pointers to show you that you don't, some situations it looks like you need to use the quotient rule, but there's an easier pattern you can use instead. Okay? The quotient rule will work if you have a quotient. It's just one of the more tedious rules to use. Okay? So let me just give you some warnings to finish off this video with. So for example, if I said that let's say I had x over 3, okay? You could do bottom times derivative of the top and all that jazz, and you would be taking the derivative of the 3 at some point, and the top would be the x, okay? However, couldn't you also rewrite this as 1/3 x? Right? That's the same thing. If you did that, then you don't have to do the quotient rule. You just hopefully know that if you have a constant times a function, then the derivative is the constant times the derivative of what you have without the constant. In this case, the derivative of x is 1, so the derivative is just 1/3. See that? No quotient rule necessary. Okay? Also, what if I had something like this? 1 over x, okay, that also looks like a situation where you have to use a quotient rule, because indeed it is a quotient. And if you did do the quotient rule, you'd be taking a derivative of 1's and x's, okay? However, you can rewrite this as x to the minus 1, and there now you can use the power rule, the derivative of a power, in this case, bring the exponent down and then decrease it by 1. Okay, look at that. No quotient rule necessary. All right. So I would encourage you, before you jump in and start using a derivative formula, try to clean it up, change the appearance into something that makes you able to use the easiest, quickest derivative rule possible. Okay. Now, as an exercise, just once, you may want to do the quotient rule in all its gory detail for both of these examples that I've written on the whiteboard, just to convince yourself that indeed you will get the exact same derivatives the long, painful quotient rule way. All right?